Okay, so part 2, taking measurements in the lab. So what is our goal? Our goal is to appreciate the importance of chemistry and use instruments to record measurements with the appropriate number of digits and units. So this time you are responsible for writing down the number, which is different from our first lecture where I give you the number and you use it. So what if you have to give me the number using say like a ruler? That's what this is about. Now, the first few slides are actually repeats of our first lecture. So chemistry is the study of change. We're going to record observations and as part of the scientific method, perform experiments to validate hypotheses and get new knowledge. And then with our units at our side, we can make quantitative observations. But here's where I want us to start on slide 6. So some digits just feel important. And as an example, I have Indiana Jones here. So maybe you're familiar with what's going to happen in this scene. So he has this little bag right here. He has there's this statue. And have we seen the movie? I'm not going to spoil anything for those of us who haven't seen it. But what he's going to do is he's going to try to swap this statue for this bag of, I think it's sand or something. The reason why he needs to swap it is because there's some kind of trap that will be released if the pressure on this button type conveyance is released. And so he's going to swap them very carefully to make sure that trap doesn't strain. But say that he wanted to use a bag of sand that is exactly the same weight as the object, this artifact here. Perhaps he has 3 options. If he is convinced that this bag that he needs to swap needs to be 20 kilograms, and he has 3 options: 20 kilograms, 20.0 kilograms, 20.00 kilograms. If he's convinced that it has to be as close to 20 as possible, then which bag should he use? The first, the second, or the third? It's number 3, right? Yeah. And we gravitate towards numbers that have more decimal places, right? It's this idea that it feels more like it's important that we have those zeros. So these are what we're talking about with significant figures. So why is it that we gravitate towards 20.00 and not the 20 with the decimal point? Well, we can use the idea of rounding. If I had a number that was written 20 with a decimal point, it means that my last confident digit is this 0. But because I measured it, there is some inherent sort of estimation that occurs when I take down these numbers. So when I say that I'm confident to the ones place, really what that means is that there's a range of numbers that all could be confident to the ones place. That range are all of the numbers that round to 20. So that could be 19.5 all the way to 20.4. All of those would round to the ones place to be 20. So this value actually has this much possibility on the number line. 19.5 would round to 20 and 20.4 would round to 20. But if I were confident to the 10th place, well, using the idea of, well, that last digit is the last one I'm confident with, well, that means that the range that this number could represent could be, 19.95 all the way to 20.04, right? Those would all round to 20.0. So do we see how the more zeros I have at the end of a number indicates a narrower and narrower range of what what could be the possibility. So 20.00 has an even smaller range of what the number could have been estimated to be. And so that's the reason why having zeros after the decimal point always sort of inherently makes us feel like it's more important, that sort of thing. So that means that there's more significance in having more of these digits. That's why we call them significant figures. And so significant figures are all of those numbers that convey our confidence. If we have a zero here in the hundredths place, we're giving the viewer or the reader sort of a commitment that I know that to that place, there should be a zero there. But how do we do that when we have to record the numbers? Well, the ones that I would like us to think about and we'll use a lot are graduated instruments, graduated things used to measure things like height. An example of a graduated instrument is a ruler. So for example, if I were to measure the height of the book, well, I think we probably have experience using a ruler. So say that the height was marked here on this centimeter ruler and it's zoomed in. So what would be the appropriate measurement that I would write down on my paper for the height of this? So we see the mark 13 here, the mark 14 here, and there are 10 little tick marks between. So what would be our value? So first of all, since this is between 13 and 14, how should I start my measurement, the writing? Should be 13, right? Okay, what happens when there are 10 little tick marks between the 13 and the 14, and I have 1, 2, 3, 4, and I have 5 here, right? So what does that mean I should put? When we use a ruler, 0.5, right? Now here's where we have to be careful, and this is our rule for using tick marks in science. Because there is space between, I can always estimate the between space no matter what. So the next decimal point or decimal place needs to be estimated. So according to this, we're a little bit below the halfway point. So we'll estimate it's about a third of the way, right? So that means that my last digit is a 3. So 13.5 and then a little bit 3. So that's how we use tick marks in science. We're going to use the tick marks to get as many certain digits as possible, the ones that we're like, yep, I can see it because I can read it myself with my own 2 eyes. And then there's always one last digit that we're going to estimate. That is how we use a ruler in science. The ruler allows us 2 decimal places, always. So anything that has tick marks are called graduation marks. They're graduated measurements. Our rule is we are always allowed to estimate 1 more digit beyond the size of the tick mark. So for example, if our tick marks are counting 0.1 inches, maybe this is an inch ruler. So, 1, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 2. So if the tick marks measure 0.1, that's the tenths place. Then that means the space in between is the next digit over. That's the hundredths place. One of the other most common instruments that we use in science are graduated cylinders. They are basically sort of cylindrical containers that have tick marks that we use to measure volumes. Commonly, we measure volumes in liters, that's the SI unit, as well as milliliters. But the idea is still the same. We'll use the tick marks to measure all of our certain digits, and then we estimate the last digit over. But one thing that's a little bit tricky about using a graduated cylinder is that liquids tend to not have a flat surface. They have a meniscus. Meniscus is the curvature you're seeing here on this image. What we do is we always read from the tip of the meniscus, the middle part where that is the furthest, in this case, down, but it could be up. Sometimes meniscuses are upward, so they could be concave or convex. The point is we always measure the middle part, the lowest part in this case, the tip of the meniscus. So that means because these tick marks are counting 50, here's 60. So the tick marks are going 50, 51, 52, 53, 54, 55. That's going to say each tick mark is the ones place. So I would say 52. And then we always estimate the in-between space. Since it's a little bit above the halfway, it's about 52.7 in this as our measurement. And if this were a milliliter graduated cylinder, our unit would be milliliters. Finally, we will be using automated or digital instruments as well. The simple rule is always write exactly what the digital instrument tells you. So if a digital instrument displays 20.00, then you should write 20.00. The reason why it has that second decimal place is because it's telling you it's an important digit. So that's one thing that I notice when we get into the lab is something to be mindful of, is that whatever digits it's displaying, that's what you should write down. Don't just write down 20, don't put 20.0, but if it's telling you 20.00, that's what you should write. So the bottom line is when you are in charge of writing the number down, if it's digital, record everything you see. If it's graduated, always count the tick marks and estimate the next digit over. As a final example, we have two different rulers with different kinds of tick marks. So what is going to be the difference in my answer if I use ruler A versus ruler B? If I were to use ruler A to measure the length of this nail versus using ruler B to measure the length of this nail, using the concept that we just learned, let's start with A. If I were to measure the length of this nail, what would I get? The length of this nail in centimeters is going to be what? So what are my tick marks counting? They're counting the ones place. So this tells me it's 5. And then our last is estimation. Our last step is to estimate the in-between space. So because 5 and 6, I have to estimate the next digit over. So yeah, depending on how it looks, I'd say maybe this is like 5.2. It's a little bit further than in that way. And then it's centimeters. Versus, what if I had more tick marks like this? What would my measurement be? 5.15, right? Each tick mark is 0.1 centimeters. So I go 5, 5.1, 5.2, etc. And then the in-between space, I have to then do one more over 5.15 centimeters. So what is the difference between these two rulers? One gives me 2 significant figures. The other gives me 3 significant figures. But the important thing is that we're always using the rules for writing down numbers appropriately. We use the tick marks to get as many digits as we can read off of them, right? And then that in-between space is going to be estimated. Now, what would happen if my measurement was right on, maybe it was right on the 5 line? right here. What would I write down? Maybe I'll just put it right there. If I had a nail where its height was right on the 5, what would I write? Yeah, 5.0 centimeter. This is another kind of trickiness because it seems like, oh, do I need to put the 0? Well, hopefully I've conveyed that zeros can be very important information sometimes. And this ruler can go to 1 decimal place. So if it were right on the line, it would be 5.0. What about this one? If it were right on the line of the 5, .00. Now, again, it takes a little practice, but we always say I can go 1 more decimal place than the tick marks tell me, or 1 more digit place, I should say, than the tick marks. So how much does each tick mark count? So 1, 1.1, 1.2, 1.3, it's going to the 10th place, right? 1 decimal place. We always can estimate the in-between space. That's going to be the 100th place. So with this ruler, if we were right on the line, it would be 5.00. When in doubt, you can always go back to, sort of the practice of just count the tick marks. 4, 4.1, 4.2, 4.3, all the way to 5.0, and then 1 more decimal place, extra 0. Phew. And that was just a short introduction to using a ruler. When we actually get into the lab, we're going to be using rulers a lot, so there'll be a lot more practice. Maybe before I end the recording, just to mention about how the sort of Canvas system works for my Chem22. So one thing you'll notice is that the modules are open for the lectures that are relevant. So right now we're in module 1. If you've taken a look at module 1, which you likely have already taken a look at if you downloaded the lecture notes, is that it's basically a complement to lectures and the textbook. It's curated material that includes extra practice videos that either I've made myself or I found some sort of nice things on YouTube or other places that help drive the concepts. There are reviews in the form of Canvas quizzes that do not count towards your grade, but are just practice, as well as practice handouts. And now for this particular lecture, there is a hard copy PDF of practice information regarding significant figures, counting sig figs, etc. And I encourage you to take a look at that. One thing to note about this course is that it is a course that requires sort of good study habits as well as time management. There is a lot of information, and I just really encourage you to make sure that you set a sort of a predictable schedule of I'm going to go and practice this today for this much time. And really, as long as there should be at least some time allotted for chemistry every day. Not necessarily that you have to do 5 hours of chemistry every single day, but really this is the type of subject that really requires sort of practice, practice, practice. So please keep that in mind. That's what the modules themselves are for. The modules also contain the homework assignments. So there is one homework assignment that is due next week that regards exactly this lecture. The homework assignments are called problem sets, and they are in the form of a Canvas quiz. However, they are not official quizzes. What this means is that you can treat it like a homework. You can have it open for as long as you need to. You can even resubmit it after you see your score. You can see your results. You can try again. I encourage you to look at the problem sets early, try them out after the relevant lecture, and see how you do, because you can always try again, and the score will be based off of your highest score. So if you get a low score, that's you can always increase it over time. So as of now, because we finished this first set of lectures, you are ready to start problem set 1. Problem set 1 is due next week. If ever you need to look at what the due dates are, those due dates are found in the calendar section. I did it in the last lecture, but I'll do it one more time. A couple things are the orientation icebreaker is due tonight. The orientation quiz is due at the end of the week. And the first kind of official assignment is called a POGL. It's a warm-up about the class information for that lecture day. It is due before class. So Wednesday by 9:30 a.m. That's when you're going to submit your first POGL. It's basically a warm-up for what we're doing in the course that day. So please keep that in mind. That POGL is found, you can get it from that central hub of information link. It's linked there, or it's starting module 2. So we finish module 1 with this day. Module 2 is our next module that is already open. And if you have any questions about anything that navigation, the course policies and so forth, again, no official sort of lecturing on the syllabus. I hope it's clear. But if there's any questions, I'll hang around right now and I'll be happy to answer those. Otherwise, I'll see you in our next Zoom meeting. I'll give you a reminder through Canvas about when that is, just because this is the first week. And then hopefully very soon, we are going to be together in the lab space. That's possibly going to be about 2 weeks from now. And yes, we finished module 1. Module 1 is a short module. The others aren't as short. Wednesday, we are starting module 2. If you haven't already looked at the I'm going to go ahead and stop the recording. It's gone on long enough.